Coral reefs host the highest fish diversity on Earth and are highly threatened. An effective monitoring is needed at global scales to come up with conservation strategies. Classical monitoring are limited to address correctly that question. Environmental DNA is a rapidly improving method, efficient to monitor marine fishes. But what about its potential in highly diverse ecosystems and at large spatial scales? Can eDNA describe the distribution of fish diversity on coral reefs? To answer this question, we analyzed 250 eDNA samples collected in 3 years in 5 regions. We clustered sequences in motus due to the limited reference database for a 12S barcode. We then compared our data to visual census realized by the Reef Life Survey during 10 years. First, we investigated if eDNA can detect the same diversity as visual methods. For this, we derived saturation curves as the number of motus and families in function of the number of samples. We found that eDNA on the left detects 16% more motus and 50% more families than with visual census on the right. The same dominant families are identified with both methods, but eDNA detects more pelagic, reef-associated, and deep-sea families. Second, we investigated if eDNA can detect known distribution patterns of coral reef fish. eDNA detects the stability of the family pattern across sites, meaning that the proportion of motus belonging to these typical reef families is constant, no matter the richness of the site, and is no different than expected at random. This pattern indicates a complementarity for ecosystem functions performed by these families in each site. And finally, we investigated new patterns uncovered by eDNA data. One of them is the higher rarity of motus than expected. As we can see here, most of the motus are rare and localized. 80% of the motus are found in only one region and 30% in only one site. Partitioning the diversity between different spatial scales further shows that 75% of the total diversity is due to inter-region dissimilarity and 14% to inter-site dissimilarity. eDNA also detects higher interstation dissimilarity, 7%, than with visual census, less than 1%, which is probably due to local environmental or habitat differences. To conclude, in this study, we show that eDNA is an efficient tool to describe diversity on coral reefs at large spatial scales. It can retrieve expected patterns and uncover new ones. eDNA could be used to increase our understanding of coral reef fish functioning and monitor fish communities at large temporal and spatial scales. Thank you.